Let's dive into RAM, how RAM is built. So there are two types of RAM, DRAM and SRAM. DRAM stands for Dynamic Random Access Memory, and SRAM stands for Static Random Access Memory, or SRAM. So they differ in how they store data. DRAM uses a capacitor, and SRAM uses cross-coupled inverters. And we'll talk about those in detail now. Robert Dennard invented DRAM in 1966 at IBM, and many others were skeptical that it would even work. But a short time later, in the mid-1970s, DRAM was in virtually all computers. So DRAM, dynamic random access memory, stores bits on a capacitor. So it's called dynamic because the value on that capacitor needs to be refreshed or rewritten periodically and every time after it's read. Well, this is due to capacitors aren't perfect. There's some leakage of that charge. So over time, the value stored on that capacitor is going to degrade, and reading a bit always destroys it. So this is called refreshing the data. And so this stored bit, we're going to now dive into what's inside that box. In DRAM, it is a transistor followed by a capacitor. And so if, for example, the word line is 1, this is an NMOS transistor, and so it allows current to flow. If there are charges on this capacitor, they're going to flow over to the bit line and start charging up the bit line. So here's an example of a stored bit being 1, right? When the word line becomes 1, those charges can then flow over to the bit line and charge that up. If the stored bit is 0, there are no charges here. So when the word line goes high, the bit line remains where it's at. It doesn't receive any additional charges. So SRAM is different than DRAM in that, well, it still has a stored bit, but we're going to store it in a way that we don't need to refresh the value. And we store it by storing it on cross-coupled inverters. And so if we have, for example, a 0 here, ignore this side for a second, and we'll get back to that in a minute. But if we have a 0 stored on our bit, and the word line goes high, well, that enables that 0 to go onto the bit line or pull that bit line low. If there's a 1 stored, word line goes high, enables the flow of charges. And this is now actively driving these inverters are actively, this inverter is actively driving that 1 onto that bit line. And so we actually have both bit line, and because of the cross-coupled inverters, we also have the data bit we want, and also the inverse on the other side. And so we also just include bit line bar, because it turns out we read, so if there's a 0 here, there's a 1 here, and we can actually read the difference between these two to help us accelerate that reading time, to make it faster to read. But the main thing is that we're storing now our bit on cross-coupled inverters instead of a capacitor. And so this is called static random access memory because it doesn't get, the value of the bit doesn't get destroyed upon reading it, right? We don't lose all our charges. This is being actively driven by inverters, and it also doesn't leak away just over time like our DRAM did on the capacitor. So here's our memory array again, and now we know what's in this box for DRAM and SRAM. And if you were asked to draw a picture of an array of DRAM, I would recommend drawing this and then drawing this once and say, hey, this is what's in that box, to make it faster. And also we're then using the principle of abstraction, right? It's a lot easier to look at this instead of, this or this drawn, 12 times. Okay, so we have DRAM cells, which where the bit is stored on a capacitor, or SRAM bit cells where the bit is stored on cross-coupled inverters.